What I'm going to talk about today is about how do we create a open communication platform, not only at its core, but also complementary services around different email services which are being used within organizations. When we talk about communication, it happens through email, WhatsApp, Facebook, and various other channels. Not only for business specific on an individual level, but also on a platform level for marketing, for supply chain level communication. Because we just think communication through different channels is only for business specific, but when we talk about business, the context changes. For different business units, the context changes, and based on the context, you have different opportunities to leverage how contextual content can help you better deliver, the end results. So eventually, your communication data is scattered across emails, chats, attachments, and different files. As users, we definitely sometimes struggle, or most of the time we struggle to find relevant context quickly because we have to reply back, we have to communicate correctly, and different formats that complicate indexing because as we have seen, we can talk in the textual format, but when it comes to different like email, chats, and attachments, we have a different multimodal approach here. So understanding that context is very important when we want to retrieve and showcase all these contextual information. Whenever we are replying in such context in different scopes. The current state of communication platforms, if we may take for example, is when you start to reply, let's say you start with a dear, sometimes you get the name of the replier, many times you don't. So that's the state sometimes. And when you type something like, I want to let, so you get a phrase there, like So you can give a tab and you can complete it. So that's the kind of contextual help at this stage. So you get a bit of help there, not the full context. And to get that, what sometimes we do is we use ChatGPT, kind of, bring this content, paste it, and ask it for help. So it kind of has its own risks. It differentiates the platform. The context changes. We are changing from the email to ChatGPT and back again. So much back and forth. How do we improve this? I think the very first is to start from the customer problem in terms of which scope are we trying to solve this for. And we'll touch base upon this towards the very last when we'll talk about some of the use cases based on this solution we're talking about. The second is, even this talk is all about how to use OpenSearch as the embeddings layer to provide more contextual information. We can improve the backend. We can put all the different layers into it to make it more improved. But I think one of the most important is, even if you have all the contextual information, how not to overload the user who is using that context. So I think user experience matters most. Even though you might not have the context, but if you're able to provide that user experience, I think you're doing a better job. And contextual information, when you bring all this information together with new text, let's say images and various other information, how not you overload the user with that information? How do you ask for permission whether the user is really interested in that? Because there's always a conflict there, whether they want to use their own imagination to drive something, or they want to use the help of the context. And the third part is communication is important because that's where we start. And more important than it is how and what to communicate to whom. So I think there's always a pictorial style in terms of, because maybe you're responding to your boss, you're talking to your colleague. It all depends on your relationship and on the tone. I think large language models are good enough to learn that on a personal perspective. So that adds, I think, the personal tone to it. But also we have to be careful enough to showcase that we are using large language models to answer these, so that we are not giving a wrong impression that this is something we have created. And the fourth is context adds value to communication. How did it get started? So I think once I had a dream or itch to build an open email platform. I was thinking what it takes to build a Gmail client. And I thought it was pretty simple enough. I just need to create what a particular UI interface, get the emails, store it, showcase it. But I think there's a lot of moving parts when you try to build such a platform. This was an initial prototype I came up with, which is open source. This is on the very first. So what happens here is you can use Amazon SES. It provides you with a lot of interfaces. So whenever you connect, let's say you're using GoDaddy, you're using Route 53 for a particular organization, you can connect it to Amazon SES, and it can start receiving emails, or you can send emails through it. So each email content is stored in the S3 bucket here. So whenever a new content gets stored in S3, AWS Lambda now processes it and stores it in DynamoDB. Here if you see there are two data sources. One is DynamoDB, which stores the metadata, like at what time the email came in, because I cannot search in S3, because all these are metadata as to when it came, from whom it came. So when an email arrives, I need to parse that all this format, like from whom it has come, or what is the attachment. And it looks simple enough when you see Gmail or any other client, right? And you see there's a thread loop, like 5 coming together, and they kind of compress it. So it looks like that's how it looks like, but eventually each email is separate. You have kind of a connector which connects one email to another. So that's how all the email services, they're connected together. They have the internal logic. That's why you'll always see a varied, kind of from the front-end interface, how different client services, they improve it or they change it, right? So with this, what happens is we always need a metadata layer to search it. That's where DynamoDB comes in, where you store what is the path of the S3 file and who and what time it has come from. So that parsing happens through a library which is present in Node.js called Node Email Parser. With that, what happens is we can now search, order, and display it in a front-end application based on React UI. Now the challenge happens in terms of when you want to search for it, because when you compare different email services, you'll see there's a popular search. So they can do keyword-based search. But here, for keyword-based search, I'm using AWS OpenSearch here. So this facilitates two particular features: listing of the emails. The second part is searching through the emails. So these two are helpful through these two particular databases, which complement each other here. Now, the goals and challenges, some of the goals which are achieved here is a simple UI. I'm able to send and receive emails, display emails, and search the emails. Challenge happens when you have long number of threads. For a particular email, you might be 20, replying 10 replies on top of it in to and fro manner. So I need some assistance in writing it. And I think that's what users expect nowadays, that they should have the context. They don't want to go through 10 emails which have happened. They want to understand what should be the reply, a summary of the email. So that is where the contextuality comes here. Now, with the introduction of these 3 layers around generative AI, particularly large language models, embeddings, and RAG, this has been made possible. The layer for the embedding has been chosen to be OpenSearch because already it is in the existing tech stack, which was searching on the keyword basis. Now, it's an open source and scalable, and it provides with hybrid search along with vector, with KNN and BM25. And it provides a very seamless connection to LLM connectors. And since search is a very complicated, and we're also looking for multi-modal, that's why OpenSearch also supports this. So it's a very good place for continuing its usage and improving it. Now, when we talk about multi-modal data landscape, in terms of communication, I'm just touching upon email in this example, but you can think about and expand it to whatever use cases you're thinking about. So it's rich, it's markup, you have audio, video metadata. You could have PDFs, docs, even code snippets, developers might be sharing it, along with timestamps, participants, channels, because those three are very important in any communication channel. So this is the missing piece in comparison to what was present previously. Now, here if you see, we have a new file trigger which happens automatically whenever a new file or a new email comes into the S3 through Amazon SES, and which is ingested into the OpenSearch embeddings layer, which can be queried because it searches based on the embedding from Amazon Bedrock. Now, if you see here, the initial architecture has been modified here. Previously, we are still relying upon DynamoDB because we still need that listing, that initial short information, because we don't want to search OpenSearch just for listing. We go to OpenSearch when we are displaying a particular detailed information or more kind of searching for it. And this is where the RAG paradigm comes in, where we are retrieving from OpenSearch based on any search, and then augmenting it using the new content plus the query of the user, and finally generating it in a natural language using Amazon Bedrock LLMs. So we are not there yet, though. Search is more semantic, although the missing piece is contextual. Now, what we have come at this point is we are able to search it. We are able to search more semantic content. But the missing piece is when users type in, they want context to be available on the real time. Like I'm typing in an email, I want more context in terms of what I could possibly write. We'll go through a particular example which I'll show, which is the end result of this architecture. Now, if you see here, the additional change which has happened is now bringing in a relational database, because I think graph knowledge plus the RAG model really shines, because sometimes the hallucination factor is really reduced, because first we are querying the graph database to find all relational or related threads, because one particular thread belongs to a parent email which was received. And when you think about the different channels the communication has happened through, the different people who are communicating, all these are factoring in a kind of a graph layer where everyone is connected. So this really shines when you query for that layer and retrieve that information. Once we retrieve that information, we can get further knowledge by querying the OpenSearch layer for those particular embeddings. So these two particular layers help us to gather a reduced hallucination level in terms of the contextual information. So the third layer, particularly which can be explored but is not yet part of the prototype which has been put in GitHub, is the tooling layer. Because what really shines is the agentic tooling behavior. When you are retrieving 4 contextual information from different channels and putting it all together, you always have different ways of replying to it. Whether it's, let's say, you have a marketing channel, because maybe you're responsible for replying to different channels, let's say to marketing, to your employees, to your customers. So each have their own context in terms of how you're answering them. So an agent specific to those would really help you to deliver those more specific, styled responses. That's how I'd say. Now, all this is very good for search and context, but how about incremental quick context? When we are replying on something, we get a response back from the LLM that, okay, this is what you can use as a context to answer to your customer, to your marketing department. But let's say I want to edit something back to it. Okay, no, respond me back with different. The response factor going back, searching to an embedding vector layer, coming back, doing an agentic tooling, it takes around sometimes 2 to 3 minutes. We don't want our customers and users to wait. We are typing, we need immediate feedback. So what do we do about that? Because we already had, if you remember, we already had the context in place. Because that's where we received the first response. We are just trying to modify on top of it. That's where bringing in an elastic cache layer for that particular conversation helps. Because we can just get the context, we have all that information, put it there, and just feed it back to the RAG model. So we have the context, put it back. So we don't need to run that whole agentic layer again. Now we are talking about just a single channel in terms of this architecture. How about improving it through a multi-layer? So that's where your chat and audio can be fed into OpenSearch vectors layer, where you have all this information. And these all can be retrieved all together when you query for it in a contextual layer. One of the challenges when you think about is privacy, because we don't want to get into others' emails. We just want to touch base upon maybe our group chats, because those are public. Depends upon your organizational policies. We don't want to go through your private chats as what you're talking with other colleagues, but more on the public group levels and kind of your emails, because that is what the service talks about. You want information in terms of what you're interacting with your own colleagues or your specific domain. So that's where your RBAC models help you, along with metadata information which are present in OpenSearch, so that you're only fetching information for your user and not going out of scope. So this is one information we can think about. So this is a customer who has responded back and they want to cancel a particular order. So if you see the ordering and they're giving us some information about the order and a date when they purchased it on, and they're giving us a reason about that. Now, with this, what happens when you want to reply to this, we can simply go, okay, we need more contextual information as to how the customer experience has been, whether they had any recent discussion with the customer service agent before coming to us finally, that they want to remove it. So this really helps, and I don't want to, if I'm a customer service representative, I don't want to go and search everything. I need this contextual information right in the email where I can respond to it. And I'm just talking about a single interface here. We can have a connected interface, let's say different chat services, let's say you're using Teams, using email, wherever you're applying, this single context could be available at all these levels from the centralized store. Now if you see at this response, so the LLM or the system came up with this 4 information. First is that it is sorry about the experience of the customer. And once feedback, that is the second layer, showing empathy for the customer. The third is also suggesting whether any other similar products, because based on the previous purchases or that order, maybe something else based on, let's say, they are more discount savvy or they are more price savvy. So we can suggest something different. And the fourth part is also based on, we're just talking about the large language model layer, but we can interface it with different machine learning models, which we can infer whether a particular discount would motivate them to purchase it. So all this information, if you see, is really contextual. It helps. It gives the reasoning. It's not just based on mere manipulative tactics, but based on factual changes as to how we can help the customer better. So these are the key benefits here which we are seeing. That is the unified search across channels, fast contextual answers powered by the RAG architecture, privacy and governance controls built in, basically starting from the metadata layer in OpenSearch. And the very fourth is the reusability in other frameworks, which I'll talk about in the next slide. These are some of the, I think, considerations we need to have, like language detection, because language matters, and multimodal really helps you when you're converting or querying across languages very easily. And it's also important to consider your PIA redaction along with GDPR, to consider what you're exposing and whether you're communicating this to your end users. So the other point I wanted to talk about is the feedback loop. It's very important that we give feedback to the system back as to whether it's helpful, because as human beings, it's always, large language models will always act as assistants to us. They cannot take decisions on behalf of us, right? So that's where they come in. And when a human being sees, because the large language models are trained on a huge amount of data, so there's always chance of jailbreaking or kind of having some bias in your text, giving more discounts to a particular user base rather than others. So it's always important to have that feedback and get your embeddings trained further based on this input. As always, it's important to bring in security and compliance, as we talked about, based on role-based access control and attribute-based filtering and OpenSearch, and having your data in transit and rest with encryption. So some of the lessons learned here, embeddings are the first-class schema elements. They're very helpful to bring you that context in a multi-turn eventual data set. It's important to also see on a weekly basis or a periodical basis what are the drift happening, because always your data set will change, your responses will change, you'll have new customers with a new profile. So it's always important to manage it and to monitor it on an ongoing basis. And the third is always to bring in your business or subject matter experts to get a feedback loop installed. This is one slide which I wanted to talk about. With my previous experience talking with some of the industry leaders, one use case which had been implemented was post-supply chain follow-up. So I think in an industry where you have a lot of turmoil in the supply chain industry, many executive managers, they work on following up on orders with different suppliers. These all happen over emails, over multiple threads, with multiple dates being missed. So all this can be automated by having this layer or by pulling in all this data relevant to, let's say, a particular supply chain executive getting all those emails which are relevant to the supplier and checking, finding what is the order. Because you can fetch this information from the ERP dataset, then compare it with what has been the follow-up, and based on that follow-up with the end suppliers as to, okay, is this order on timeline? Because that is how it has been happening. But this really gives you a kind of a proactive approach to follow up with your suppliers. The second is we talked about is the contextual emails, where it adds value to get more information when you're replying back. The third is complementary business and contextual data. So whenever you're, like we talked about the sales and marketing emails, so these are emails in a contextual layer, but we can build complementary services on top of it by bringing this data, approaching it, creating a context around it, and kind of having a platform where you can reply at a multiple channel level. So some of the future roadmap is streaming RAG, because this usually gives you the whole data. With streaming, what happens is you're getting chunks of data, which gives you a nice experience in terms, because you can see the data being populated or not waiting too much. The second is the fine-tuned local small models, because it really helps when you have small models with contextual data relevant to only your business domain, which many organizations are working upon, because that gives you a faster access to the response. So this is about me. Some of the books I've written and a 20% discount from Apris if you're interested. Okay. And that is about, thank you.
Nice talk.
Thank you.
Questions? Questions? Okay, then I will go with my question.
Sure.
So if you can go back to one of the architecture diagram that you have, right?
Yeah.
So do you have the email thread itself in the OpenSearch? I mean, you create the embeddings and then you put embeddings in the OpenSearch, or it's just the metadata?
So it's just I think it's all about the content of the email, not all the threads.
Okay.
The threads are kind of, you have kind of a overlap in the thread, so that one thread is, you have some overlap there. The principal relationship between all the threads come from the graph database. So that's where all the connection comes in. So if you're searching for something, you get a very quick response, because eventually you don't want so much context in your prompt. You have to search through a huge data in the OpenSearch. Instead of that, the metadata is maintained in the GraphDB. You get all your election context. You get the people who have connected, the channel they have connected on, and the different contextual content which is present. Once you have that, this can be passed into the OpenSearch to get further information for those specific emails.
Yeah. Do you see this becoming a Outlook plugin?
Absolutely. I think when you think about this, this can be plugged in if you think in Outlook plugin. If you think about Teams, you can build an app in Teams where you're chatting, and you can send an email from the chat itself by just bringing in an app agent. So you just say, send an email, this is the context, you know who are in the email, and just send it. So I think it's all about the interconnectedness of things. I don't think in the future you just need an email to reply, go to a different context. You can do all this from a single chat interface by just calling different agents. But eventually you have a large language model which is acting as an agent, but you also have different agent apps which can call different agents, like communicating off different agents together.
Any questions? If not, I have one more question, but I don't mean to put you on the spot, because it's a bit specific. So, do you have the insights on the model that you use for the vector search, the embeddings in OpenSearch, and what space type and those things? And did you use any quantization within OpenSearch? If you have some insights, yeah.
So with this one, I've not used quantization in particular. The model which was, it was more based on the image model, which is based on the Titan. So that is the multi-modal which I've used. And that basically takes the text and the image together. But for the audio, I think it's not supported yet in this, but I think we have to see.
Thank you. Then, a round of applause. Nice talk. Yeah.
Thank you so much.